This is screencast number 4 for Unit 4, Lesson 3. I'm on page 210, and I'm looking at the blue heading that says, what is Newton's law of action-reaction? Newton's law of action-reaction, or Newton's third law of motion, states that whenever one object applies a force on a second object, the second object applies an equal and opposite force on the first object. Okay? The bottom line for this law is the little red heading. All forces act in pairs. Every force has an equal and opposite reaction force. Okay? Down at the bottom paragraph where it says action and reaction forces do not act on the same object, that is really important for you to underline and understand. Also, where it says the forces are equal but acting on different objects and in opposite directions. Okay? One of the very frequent questions that I get during this unit is if forces are always equal and opposite, then how on earth do we get unbalanced forces? And that's a great question. But if you think very carefully about what we just said, the action and reaction forces are not acting on the same object. And in order to know what's happening with a particular object, you have to look at the forces that are acting just on that object. Okay? So down at the bottom of page 210, I put a little reminder, a little explanation about what I just said, and it's abbreviated a little bit, but basically what it says is, if forces occur in pairs, meaning always equal and opposite, then how do we get unbalanced forces? We get unbalanced forces because those equal and opposite forces act on different objects. And I'm going to show you an example of that. Hopefully that'll make that point a little better in just a second. All right, I'm on the back of Lesson 3 under the My Notes section, and I have sketched a little stick man. Sorry, my drawing's not any better. But I drew him with his feet on the floor, and he's pushing against a wall. And if you've ever tried to do this, you know that probably you're just going to sit there and push and you're not going to go anywhere unless your feet slip out from under you. But let's just assume that you've got enough friction between your the soles of your shoes and the floor. So you're not going anywhere. You're just pushing on the wall. Well, there are a lot of forces actually involved in this situation, and we need to point out all of them so that we have a thorough understanding of all of the forces that are acting on the man at this point. So there's actually 4 pairs of forces that are involved here. Pair number 1, the man is pushing on the wall. And the wall is pushing back on the man. There's another one down here. The man pushes backward on the ground pushes the man forward. Okay. There's another one. The earth pulls down on the man, and the man pulls up on the earth, if you can believe that, but that is an action-reaction pair. And then the fourth one is the floor pushes the man up and the man pushes the floor down. So you have 4 pairs of action-reaction forces. But in order to understand what's going on with the man, you need to look at the forces that are acting on the man. So one force out of every pair is acting on the man. So now what we're going to do is we're going to look at just those forces acting on the man. And you do need to be writing this down as we do this. Okay, so here's our little vector diagram for just the man. And you have the force pushing up on the man, opposite of the earth pulling down on the man. Those two balance each other. The wall pushes the man to the left, the ground pushes the man to the right, and those two balance each other, which is why he's not going anywhere right now. Okay? So to thoroughly understand Newton's third law, you do have to keep in mind that yes, forces are always equal and opposite, but they don't always, well, they don't act on the same objects. Okay? Please make sure you sketch this under your notes because this will be part of your assignment for Lesson 3.